Thank you very much. Yeah, I just got back from playing tennis nationals in Las Vegas, so that was fun. Thanks for attending my talk. As you can see, I love JavaScript, and there's actually an accessibility problem with this T-shirt, with this shirt. I don't know if any of you can see it. That would actually get detected with the tools I'm going to talk about a little bit later. The color contrast of the eye is not that good, but so I was actually doing a little bit of research for this talk, and of course, I went to the place you go to if you want to find the real truth about anything, the internet, Google. I was trying to look for some kind of personifications of JavaScript because I love JavaScript so much. And I found out, strangely enough, not everybody likes JavaScript as much as I do. I saw this on a place called Leftover Salad. For those of you who can't see it, it's kind of, I don't know, it looks like some kind of cancerous growth with eyes all over the place saying, I'm technically functional, and that's JavaScript. So I didn't find this funny at all, but some of the other ones for the other languages were really funny. This one for Java, this is funny, yeah. And then for a little bit more up-to-date one, Rust, I thought this was funny. I'll be designated driver tonight, we know. Don't talk while eating, you could choke and die. So yeah, so those ones were funny, but the JavaScript one was not funny at all. So I went and did some more research, and then I found somebody who said that JavaScript is like Ginny Weasley. I was like, that's interesting, why? And it's because they said, well, that's the one who cries when all the other proper languages get on the train to go to school. And I thought, that's not nice either. There must be a better one. There must be a better one somewhere. And then I found this website that said JavaScript's like Tyrion Lannister. Because it's a little bit quirky, but gets a lot of stuff done. So I thought, that's better. But it still wasn't quite what I was looking for, so I decided to kind of make my own persona up. And that's when I realized that really it's not just JavaScript that we're dealing with when we write web applications, really the kind of the tech triumvirate, I don't know, the holy trinity of the JavaScript, HTML, and CSS that really makes up our application. So I thought, okay, if I'm going to make one up myself, then I'll make one up that has to do with these three components or these three technologies, because that's really what our apps are all about. And so I was thinking, well, what's common about these three? And really, the thing that they have in common, and the thing that all of us are dealing with every day when we're testing, is that they were made to be robust. So HTML, for example, if you put a tag in that doesn't exist, the browser will just like, whatever. If you don't close a tag, the browser will be, whatever. It'll close it for you, it'll just ignore it, it'll do whatever. If you put an attribute that doesn't exist, the browser will just ignore it. And CSS is the same. If there's stuff that the browser doesn't understand with the CSS using, it'll just throw it away, carry on happily. And if your JavaScript event handler crashes and throws an exception, doesn't matter. The other JavaScript event handlers will just work just fine, right? So and if your HTML references a resource that doesn't exist anymore, the browser will just ignore it and carry on. And so it's kind of great in a sense. And so I thought, well, what person is like that? And I thought, well, a Deadpool, right? Because you can't kill Deadpool. Deadpool just carries on. You cut his arm off, he just carries on, blows himself up, carries on. And that's really what our web applications are like, in a sense, is that there's no compiler that's going to tell you if all of a sudden something that used to exist doesn't exist anymore. You have to actually go through your entire application and test every little bit of it in order to find out that something that used to exist doesn't exist anymore, or some type changed, or somebody put the wrong type into a variable and now it blows up, right? So what's the upside of being Deadpool? You don't get drunk. He can't get drunk as much as he tries. And I found out why this is an advantage when I was on a train between Moscow and Yakutsk, the Trans-Siberian Express. And somewhere between those two places, it takes you 3 days to get from the one place to the other. These Russian soldiers got on the train and went into the cabin next door. And they were very nice. They invited me and my girlfriend over to have some drinks with them or some food. And they brought out 3 bottles of vodka and put them on. And they said, you're not going anywhere until these 3 bottles of vodka are finished. And that's the upside of not getting drunk if you're Deadpool, is you can actually survive something like that if it happens to you. So what's the upside of not breaking as a kind of an application development environment? The upside of not breaking is that we have to invent tools like this to help us to test all these things so that we can actually find out whether our application still works. And I think that's a real advantage. We're all here today because of Selenium, which was invented to kind of deal with the testing problems that web applications created, right? So you should all be asking yourself, well, I thought this was an accessibility talk. What does all of this have to do with accessibility? Well, accessibility, I wanted to come up, the reason I wanted a persona for JavaScript is I wanted a persona for accessibility as well. And I came up with one, and it's Mewtwo. So who plays Pokemon Go? Anybody play Pokemon? Yes, look what I have. I have my Pokemon Go Plus in my pocket. So while I'm talking to you, I'm actually catching Pokemon. There you go, see? So yeah, I'm addicted to this game a little bit. So why is accessibility like Mewtwo? Well, first of all, accessibility is extremely powerful. I mean, if you're making your application accessible and you work for an educational institution, then you're making a difference in somebody's life. You're allowing them to, which can help them to get a job, which is a really powerful thing to do. To give you an example, we have an online courses, DQ University, where you can learn about accessibility, and we give free scholarships to anybody with a disability. There's like something going on with the sound. Are you guys on top of that? Let me know if there's anything I can do to make it better. Anyway, so we give scholarships to people with disabilities. They can take all of our accessibility courses for free. And we were at a conference recently, and this guy came up, totally blind, and he said, you know, I went to university, I studied engineering, I learned how to program, and, you know, then I got this job and that job. Sure. Good. Do you need a switch? Okay. Is that a bit better? And he said, you know, I had, you know, some odd jobs, couldn't really hold on to a job, and for the last 3 years I've been unemployed. And then I went onto your DQ University site. I did all of the courses for free, which you guys gave me, and now I'm working for Google. And that's the kind of power that, you know, in a way that accessibility can have. So Mewtwo is a very powerful Pokemon. And in that respect, accessibility is like Mewtwo. But it's also like Mewtwo in another respect, because Mewtwo can be invisible if it wants to be, right? And accessibility is, a lot of accessibility is invisible. And so that's why I think that accessibility is like Mewtwo. So let me give you some examples. This is, if you go to the MDN website, the Mozilla Developer Network, and you look up a web form, this is the example of the web form that they give you. Looks pretty cool. There's a login button, user ID, and a password. I looked at the source code for this, and this is what the HTML source code looks like. And everything is cool. The input is type equals image, which is an interesting choice for an input button like that. Why do that? But they did. But they've also done the cool thing. They've taken the image, the input, and they've added an alt attribute to it, which is great for an input of type equals image, and they've added login to that. So that's great. So what happens if the next developer comes along and deletes alt equals login, replaces that with something else? Maybe he replaced the image changed or something, replaced the tag and forgot to put the alt equals login back there. What would that do to what that form looks like? Well, nothing. It would look exactly the same. And that's why a lot of accessibility is about being invisible. Color contrast, like the I in my I love JavaScript on my hoodie over here, that's one of the few visible things that has to do with accessibility. Most of accessibility is actually invisible like this. So let me give you some other examples of things that are very important for accessibility, but are mostly invisible to sighted people, like most of us in this room. So that second one there that you have is a list item, which is very common for doing things like drop-down menus. List item role equals menu item. That's great. Tab index equals 0. What is that? What do those two things do? The tab index equals 0 makes that list item, which isn't otherwise keyboard accessible, makes it tab focusable. So when I tab through the page, I'm going to be able to tab onto that list item. That's great, because if I want to add keyboard accessibility to my drop-down menu, then I need to make that keyboard focusable first of all. And the role equals menu item is also important because even if it's keyboard focusable, if I don't have that role equals menu item and I turn my screen reader on, if I'm a blind person, if I come there and I try to interact with that menu item and use, say, the keyboard event handlers that are attached to that, they won't, the JavaScript events won't be delivered to that list item unless I have role equals menu item on that, because what that is telling the screen reader is when the screen reader focuses on this item, please turn it into what's called forms mode. And what forms mode allows is it allows the JavaScript event handlers to be passed through, bypassing the kind of interception of the screen reader itself directly to the JavaScript. So those are two elements that if you removed one or both of those, you would break your accessibility. The second one is what's called for ID association, where I've got a label and I've got an input field, and I've associated those two using a for ID. And what that does is that if a screen reader user tabs into that input field, it'll read out the label because it knows that that label is associated with that input field. Once again, it's a very important attribute for accessibility, but it's invisible to most of us developers. So if somebody comes along and changes that, it breaks the accessibility. So there's a lot of these sorts of things that are completely invisible that are very, very important to accessibility. And what we've done is we've taken a lot of that logic and put it into this open source library called ACAAct. And by using ACAAct and the associated components and modules, you can actually find a lot of these things without a lot of effort on your part. Obviously, going back, you could write unit tests for each and every single one of these things, right? If you know what to look for, you could write unit tests for those and you can automate all of those. But that's a lot of work. And so what ACAAct does is it takes a lot of that away from you having to do that. So what are some of the highlights? The first thing is we focus on 0 false positives. Why is that important? Anybody here ever break a build that wasn't a real problem and really get into trouble for that? How many people? Yeah. Developers don't like it when their build breaks and it's not a real problem. So what we've really focused on, kind of in contrast to a lot of the other accessibility tools out there, is making sure that if we tell you there's a problem, that it really is a problem. That means that our rule set is much narrower than some of the other tools out there. But the fact that it's narrow means that you can really rely on the results of it. So that's one of the first things we focused on. The second thing is, even with that relatively narrow rule set, we find that you can find about 50% of your accessibility issues by volume. So we did a very big study with a large insurance company, State Farm. We did manual analyses of about 65 different applications, and we ran the automated testing against those same 65 different applications. And we found, after we analyzed all the results, that the automation found 50% of the issues. What we had to do was take all the color contrast issues out and throw them away because there were so many of them that it just overwhelmed all the tests. So we threw those all away, and still it was over 50% of the issues that we were able to find automatically. And so that's pretty much as simple as you can click a button and it'll find half your issues for you. The second thing about ACAAct is it works in any browser. It even works with things like JS DOM. So you can put it in your enzyme tests, you can put it in and run it on in emulator browsers, you can run it in Safari, you can run it in IE even, you can run it in Firefox, you can run it in Phantom.js. It'll run in any browser environment, even some of the emulated ones like JS DOM. It's fast and it's lightweight, so we've paid a lot of attention in this latest release, 3.0. We actually had some help from Paul Irish from Google, and really paid attention to speeding it up, and were able to get over 50% speed improvement. So you can run it against, if you run it in your unit tests, you run it against your fixtures, and it'll run in milliseconds, literally milliseconds. It also supports Shadow DOM, so if you've got components with Shadow DOM, it'll look inside the Shadow DOM, it'll emulate what the screen reader accessibility tree looks like across the Shadow DOM boundaries, and it'll find problems where, for example, say you've got part of your component is a menu, part of the menu is actually inside the Shadow DOM. It'll actually make sure that the hierarchies of all the various different ARIA attributes and that sort of stuff, those relationships are correct across the Shadow DOM boundaries. It also supports cross-domain iframes. It's the only tool that does that, and it's open source and it's free. And we've recently added the first rule for the new version of the Web Content Accessibility Guidelines for 2.1. So we actually have one WCAG 2.1 rule now, and we'll be adding some more later. Okay, so how do you get hold of this and how do you use this? First of all, we have an extension called the ACAAct extension. It's available in the Chrome store and it's available in the Firefox store. So it's as simple as going, if you do a Google search, ACAAct Chrome extension, it'll be the first result that'll come up in your Google results. You just install it and you're off to the races. This is what it looks like if you open up your DevTools after installing it. It appears as a tab in the DevTools. You click on that tab and you'll see this screen pretty much. And all you have to do is click the Analyze button. And then it brings up a list of the issues on the left-hand side by rule. So it'll tell you how many rules you failed. By default, it'll show you everything, best practices, violations, and what we call review items. And you can then go through those one by one. For each of the rules that you failed, we'll show you all the different nodes that failed that rule on this page. So you can see there, once again, color contrast, my favorite issue because it's very reliable. You can find it everywhere. There were 74 different elements on the page that failed that rule. And you can step through each of them. It'll show you the source code. It'll tell you where it got the background from and what the background and foreground contrast are if it's a real issue. It also allows you to review the review items. So there you can see this is a review item where it says, I couldn't tell the background color or the foreground color reliably. I needed to go and help me make a decision on this one. Very important is, in the top right there, you can see the Learn More link. A lot of you are working together with developers and you bring them these lists of issues and they say, I don't know how to fix these things. Just by clicking on that Learn More link, they can get to our DQ University site. And the DQ University site, for each and every one of those different rules, has quite a lot of information. First of all, it has information about why should I care about this? What sort of people are going to be affected by this? What disabilities? Why does it affect people with that disability? So there's information to kind of help the developers get more empathy and understand more about why is this a real problem and why should I fix this problem. It describes the algorithm in simple terms so they can understand what the system is looking for in terms of trying to determine whether something was an issue or not. And it'll also give a lot of information about what the various different standards are that are being violated by this particular type of issue. More importantly, it gives a lot of different examples of how to fix this particular violation. So in this example, this is a button that doesn't have a text, and there are various different ways you can add an alt text to a button. You can do it with an ARIA label, you can do it with a title attribute, you can do it with inner text and a button element, and it'll give you examples of each and every single one of those so that you can choose the one that's most appropriate for the way that your web page is built. So the second way you can get hold of it is by going to npm and just npm installing the ACAAct core library. So npm install --savedev ACAAct-core, and you get the JavaScript library. And then you can embed it into all your existing tests, whether these are functional tests, unit tests, whether these are functional integration tests, or whether you're creating a specific test suite just for accessibility. It's very, very, very easy to integrate this into your tests. All you do is do require ACAAct core, very simple. Then you set up your fixture, you do your functional testing, and what you want to do when you're integrating this into your test is you want to make sure that you're testing each unique user interface state. So there's a small difference between pure functional testing and accessibility testing, in that in functional testing often you are not interested in some of the interim steps. So for example, we had a customer, a hotel group, and their application is a lot of the time is about the options that you want. Do you want a smoking room, non-smoking room? Do you want two queens? Do you want one facing the water or one facing away from the water? All these various different options. So what their functional test suite did is on the search page, it would enter all the options for the search. It would then jump through the selection screens without even looking at them. In fact, they'd written a little function to automatically select the first one, a result that comes back, and then it would go to the confirmation page where they could then confirm that all the room that they'd selected actually had all the options that they wanted. So their functional testing skipped over these interim screens. And what we had to do when we integrated the automatic testing into this for accessibility is we had to break those apart and say, okay, for at least one or two of those instances, we want to make sure that we're testing those interim screens to make sure that they're accessible. So that's how accessibility testing is a little bit different from functional testing. But for the most part, you can take your existing functional tests, and simply by doing a require like that, you can then add 3 lines of code to just run that against that fixture or against that document. And so what you do when you run ACAAct core is you say ax.run, you pass it the context. Now you can either analyze the entire page or you can analyze a portion of the page. And ACAAct is intelligent in that it'll, depending on what you pass, it'll turn certain rules on or off. So for example, you may be familiar with a skip link. There's a requirement to be able to jump directly to the main content of the page if you're using a keyboard. One way to do that is with a skip link, but that's only required if you're analyzing the entire page. If I'm analyzing a portion of the page, I don't want to run the rule that looks for a skip link because then it'll generate a false positive. So ACAAct knows whether or not it's running against the entire page or just a portion of the page, and it will turn those, what we call page level rules, on and off automatically for you. So you can pass it the fixture. There is some options you can pass in, so you can turn particular rules on and off. You can have your own custom rules that you can give it if you want to write custom rules. So there are options. You don't have to pass them in. And then you give it a callback, and when it's finished with the analysis, it'll call the callback with the results, and you can just do assertions on that. By default, you want to do assertions on just the violations. So a good assertion is assert that the results.violations array, that the length of that array is 0. That means you passed all the tests. That's a very simple assertion. There are, in addition to the violations, we pass back the results of the what we call review items. We'll also tell you which rules didn't run at all on the page because there was nothing applicable on the page. So we pass back what's called a list of inapplicable rules. So you can actually use those statistics to generate also reports if you wanted to generate reports. And then you just call done when you're done with that. So it's really simple to integrate into your application. So this is obviously Node or JavaScript. There's an equivalent function you can call if you're just doing unit testing in the browser. It's very similar to that. But we have a bunch of other projects that you can use. So for example, if what we find is a lot of companies, they may not have functional tests that cover the full breadth of their application, but they still want to do some accessibility testing, automated accessibility testing for that application. So what we wrote was a command line interface that you can use to just call from the command line to do the same thing. So let me actually show you what this looks like. I have to go and use my screen over here. If you do npm install -g ACAAct, it'll install this application, and then you have an ACAAct command that you can call. I'm calling ACAAct https://npmjs.org. What it's doing is it's actually using WebDriver and Chrome, loading that page, waiting for the page to render. It's injecting ACAAct into the page and all the iframes on the page, analyzing that, returning the results, and then it prints it out to the console. So here you can see the exact same sort of results that you're getting both inside the browser and inside that JSON object that gets returned by the function call. So just let's pick one, duplicate ID. It says violation of duplicate ID with 2 occurrences. It gives you that kind of summary of the violation to tell you what's wrong with it. And then it gives you the 2 selectors. So we always return selectors so you can identify the elements. It's going to give you the 2 CSS selectors for those 2 elements that failed. And then, once again, the link to that more info page on Deakin University so you can learn about it. So that's the basic kind of report that you get from ACAAct. And it gives you an alternative way to run this if you don't have your own test suite. Obviously, there's some limitations with this. If there's a login or something that you have to go through in order to get or some kind of workflow you have to go through to get the application to the correct state, this is not going to help you. But it gives you some good basic testing capabilities for some static applications. Another example of an integration that we've done, how many people here are using React for their applications? Quite a lot. So ReactX is a module that you can download and you can embed into your application that gets kind of compiled in if you're in development mode. Once you do this and you compile it into your application development mode, then what happens is it appears in your application. If you go in your Chrome browser and you open up your application and you open up the dev tools, what it'll do is it'll actually analyze the application dynamically as you exercise that inside your Chrome browser. So let me show you a little video here of how this works. So I've got my React application over there, and I've got the dev tools. I opened the dev tools up and I loaded the page, and it automatically analyzed that page for me. Once again, you got exactly the same sort of information in the dev tools console as you had before. As I interact with that application, what it's doing is it's detecting the changes dynamically, and it's running the acts against those changes, but just the portion of the application that changed. What it's also doing is it's actually deduplicating those. So if I run the same, if I exercise the same code and make the same changes to UI over and over and over again, it won't print out those issues over and over and over again. It'll actually say, okay, I've already detected this one, I'm not going to report that one again. So it's another example of a tool that we've created built around this ACAAct core library that integrates pretty well into the developer's kind of dev environment. So there's a bunch of other integrations. There's an ACAAct WebDriver IO integration and an ACAAct WebDriver JS integration. Very similar way that you can call these to what I showed you with the basic ACAAct core library. The difference is that what we do in some of these integrations is we will crawl the page, find all the iframes, inject ACAAct into all the iframes for you, so you don't have to do all that sort of work yourself. Makes it a little bit simpler. All you do is you instantiate an object, give us a WebDriver instance when you instantiate that object, and then every time you do analyze, we'll go and do all that work for you and just pass the results back. So we have one for Node for WebDriver, WebDriver JS. We also have a Java one called ACAAct Selenium Java that works with Selenium, and we have a Ruby one called ACAAct Matches, and they all do pretty much exactly the same thing. They just have different language bindings. All of them work with Selenium or something that's Selenium compatible. So the ACAAct Matches will also work with, I forget what the other, Water. There's Water, and there's some of the other drivers that it'll actually work with as well. And then there are other community projects. So ACAAct is pretty widely used right now. I dare say it's probably the most widely used accessibility testing library today. Google has integrated into Lighthouse. So if you open up your Chrome DevTools and you go to the Audit tab, the accessibility audit that's running inside Chrome DevTools is actually the ACAAct core library. So you're getting exactly the same things. What they've decided to do, the one difference is they decided to turn certain rules off. So it's only a subset of the ACAAct rules. And they also decided that they weren't going to focus on iframes. So if your application has iframes, they'll just be ignored when you're using Google Lighthouse. The user interface isn't quite as good as the ACAAct user interface either, but it's great because it's everywhere. So you have it, and all your developers have it as well. Then LinkedIn wrote the Ember Alley testing library for Ember. Microsoft has a product called SonarWall, which is kind of like their version of Lighthouse that uses ACAAct core. There's an ACAAct Puppeteer project that wasn't developed by us, that was developed by somebody else. We're in the process of actually integrating that into our open source project, so we're going to take that over eventually. And then there's a very good automated accessibility testing tool called Pally. They originally run with what's called the code sniffer rule set, and they're currently integrating the ACAAct rule set into that as well, so you'll be able to use the Pally accessibility testing tool to run ACAAct as well. So what's coming next? We have a very actively developed open source project with us. There's 74 contributors. If any of you have ideas for how it can get better, please come and contribute. We're looking for contributors not only to write new rules or to actually change the code, but also help us with test cases, help us with documentation. So we really welcome all different sorts of contributions. So please come and take a look at the project and see if there's something you can help us with. So we have a very active community around this. We're currently working on improving the rules. We're going to be splitting certain of the rules apart, making them much more targeted in terms of which rules you can run at various different times. So for example, there's a type of violation called duplicate ID. Under certain circumstances, a duplicate ID could really be a blocker. So for example, if you have 2 buttons on a page and both of those buttons have the same ID, then if using voice recognition software, regardless of which one you wanted to click, it'll always click the first one with that same ID. So that can be a blocker for somebody using that sort of assistive technology. But under other instances, a duplicate ID could be, meaningless, have no impact. So what we're actually doing with our rules is making it much more differentiated whether something's an interactive component or not. So there's a lot of rules improvements like that we're making. We're also actively working on WCAG 2.1 rules. We have one other WCAG 2.1 rule that's experimental right now, and we're going to be working on some other ones. For those of you who are interested in trying out the more experimental stuff, we have a second extension called ACAAct. So once again, just Google ACAAct, and you'll find it in the Chrome store. And the difference between the ACAAct and the ACAAct extension is the ACAAct extension turns all the experimental rules on. So you can actually help us. One of the ways things you can do if you're interested in contributing to the ACAAct project is download the Coconut extension, run it against a lot of different applications, and help us to figure out whether those experimental rules are working well or whether you can find false positives with them. We're also actively working on linting support, so that you'll be able to run the ACAAct rules inside something like ESLint. And that's something we expect to come in the next year or so. There's an exciting new project from a partner I can't talk about too much, except to say that I'm really around about March next year. Keep your eyes and ears peeled, because there'll be a big announcement at CSUN, a big new project, open source project that's embedding ACAAct core into it is going to be announced. Very exciting stuff. And then we have our own, what we call Project Walnut. ACAAct is great in that it can find about 50% of your problems automatically, but it stops short of getting you to the 100% or even the 80% mark. So what Project Walnut is our attempt to take ACAAct to that next level, to help people who are not accessibility experts to find the stuff that cannot be fully automated. So in about 4 to 6 weeks, inside the ACAAct Chrome extension, you'll start to see some calls to action where you can actually register to participate in an early beta program for that Walnut project, and we'd really appreciate you helping us to figure out whether we've actually hit the mark with that application. So keep your eyes peeled for that as well. So that's everything I was going to say. I think, do we have time for some questions, if there are any questions? Otherwise, I'm going to be at the office hours directly after this.
Yeah, it'll be the... Let me walk away from my speaker. It'll be office hours.
Okay, excellent. Thank you very much.